Hi friends, welcome to our channel. Let's look at a newly appeared problem, closest equal element queries. In this video, we are going to first give you a walkthrough for example 1 to digest the general logic, and then you'll be able to see what data structure or strategy we shall use. So let me write it here. Our plan will be first walk through example 1. So this will help us digest what data structure and method we shall use to address this problem. So with that said, let's first quickly look at the problem statement and then look at example 1. So here we are given an array called nums, which is circular. And also we were given a array called queries. So for each query I, we have to find the following. So the minimum distance between the element at index here, queries I, and another index g in the circular array, where the nums g and the current query index have the same element value. If no such index exists, so the answer for the query shall be -1. So that's actually the problem statement. Actually, the hard part lies in 2 points. So one is the array is circular. The second is time complexity, because the array length and the query length can be as long as 10 to the power 5, right? So here, let me go over through example 1. So in example 1, in example 1, so I guess, so if you count all the elements, so let's see, if you look at, let's make a dictionary, right? So for element 1, it appears in index 0, let me write it here, index 0, 2, and 4, right? And then for index for number 3, it appears in index, so this is 1, right? 1, 2, 3, 4, 5, 1, 5. And for so we have checked 1 and 3, then 4. 4 appears just at 0, 1, 2, 3 at the index 3. And also we have a 2, right? So 2 appears only at, so this length is 7, so it's at index 6. So overall, we have 3, 2, 1, 1, right? So now let's look at the return. So for index query 0, so which is 0, right? So 0 corresponds element number is 1. So we want to find the nearest one. So here, if you check the index here, this is 0, right? So the nearest one is either the distance between 0 and 2, or you can go backwards, right? So here you have 3. So the smaller of 2 and 3 is 2. So therefore, the return is 2. And for query at index 1, so the query is 3. So nums at 3 is 4, right? But 4 only appears once in this circular array. Therefore, we should return -1. This is rather natural. Then for query at index 2, so it's 5. And nums 5 is, let's see, 3, right? Let me check. 0, 1, 2, 3, 4, 5. That is 3. So 3, so for index, you know this is the index. Then there are 2 possibilities, right? So either we should return the minimum, either this distance, that is 5 minus 1, or we use, so we count this one and then count this one, right? So 3, this guy, and this guy, and this guy. So here is 2. Here is 1. Overall is 3. So this is nothing but, the length of this array, that is 7, minus 5, this index, then plus the first occurrence index, that is 2, right? 2. We should minus 1, right? So 7 minus, so here actually this index will be 6, so we can use 6, or you can use length minus 5, then finally you minus 1, right? The same thing. So here this 3, so we are going to return 3. That's actually the same. So from this walkthrough, actually we can realize, so we should use a dictionary, right? Dictionary to store the indices where each unique elements appear. This is the one. Another way is an efficient way to search, right? So for example, here query 2, that is 5, right? So for this index, we need to search the 5 index. So here in this example, this is very short, but if you think of the length of this array, so this can be very long. So here actually, because we are storing indices, so these indices must be in sorted order, right? So because each appearances or indices list corresponds corresponding to a unique element is for sure sorted, strictly increasing. So this actually enable us to use binary search. This is exactly what we are going to do. In other words, we have 2 ingredients in this solution. So one is a dictionary, the other is a binary search. As we are going to use Python, we can use bisect module, right, in Python. So with that said, I guess let's carry out this program step by step. First, I'm going to get the length of this nums, so for convenience, nums. And also we get the length of queries. I don't know if we need to use it or not, but let's write like this first. So we also initialize a result list. So this its final state is what we want to return. So now I'm going to build this dictionary. So we're going to use the collections default dict. So let's have a container list, right? Then we are going to iterate through this nums list. So for I, y in enumerate nums. Then the value is the y. So we are going to append this index to the array. So up to now, you can actually print out this d so that you can have a feeling. So let's see if our walkthrough is correct here. Yeah, here we have 1 corresponding to 0, 2, 4, 3, 1, 5, 4, 3, and 2, 6, right? So with that done, now let me continue. So next thing we want to do is to get the result for each query. So for query in queries, if I write like this, I don't think we're going to use this m, but let's first put it there. So first I'm going to get the value corresponding to this index. So nums query, right? Then the corresponding array will be you check the value and then you get this kind of array. So that's going to be the value, right? So first we treat a very simple case. Let me also introduce length of this array. So if length is less than 2, it means that this value appears only once in the whole circular array. For sure, we need to append the result with -1. This is the one case. So now let's treat the other case. So for the other case, we are sure the length of this array is at least 2, right? We can use binary search. So idx, let's first get the insertion point. So we are going to use bisect left, right? So the search space will be the array, and the value we are going to search, or the index we are going to search is q, right? So because here we are using bisect left, so left to this idx, all the elements in array is strictly less than this q. In other words, this idx would be the exact index of this index q in this array, right? This is important to be realized. So now let's consider different cases. First, if idx equals 0, so in other words, it's the first element in this one. For example, here, right? You have q is 0. So if you search 1, this is the one. Then the distance would be this guy minus this guy, and then you also consider the circular part. So in other words, so this will be, let me use a temp. This will be minimum of array 1 minus array 0, right? This you can think of as 2 minus 0. And then what we are going to do is array 0. So starting from the current one, and then plus n minus array negative 1. So then basically we from 4 we move to the end, then move to the occurrence of the current value or current index. So this is the one. Another one is idx equals length minus 1. In other words, this is the last one. So the temp would be min array idx minus array idx minus 1. And then we move from the last one to the end, and then to the first one. That is n minus array negative 1, then plus array 0, right? So the second one. Otherwise, it would be in middle. In other words, the length should be at least 3 in this case. So then the temp would be the min of array idx minus array idx minus 1, and then array idx plus 1 minus the current one, idx. So then what we are going to do is to append the current temp to the result. So now after this for loop, we just need to return the result. So this actually forms a full code for this problem. So I guess the major part is this two, this one and this one. If you cannot figure out this ingredient here and this ingredient, you can walk with an example to see if it's the case. So now let me first run it to test. Yeah, it passes all the cases. So now let's look at the generic case. Yeah, it passes all the cases. I guess that's the coding part for this problem. So if you would like to do temp complexity analysis, it's also straightforward. Here, for example, this one, let me first comment this out. And let's see, you do this one. This is ON operation, right? This for loop. And then for each query, basically assume that you participate the indices into, you have key unique values. And then the length of each of this indices list will be, say, A1, A2, up to AK, right? So here I'm using one indexing. Then when you do this, so this query, let's see, assume its length is m. So for each one, you are going to do a search essentially. So the search will be a logarithm, right? So logarithm a of I, right? Then because for each query we are going to do one, right? So what we are actually doing is to sum all those for I in 1 to k, right? So basically you do m such search, right? So basically I'm going to do for m for some of the i's, right? Some I. So let's write I corresponding to some, let's say I naught or I bar, right? But each of those is bounded above by the full length, right? So which is less than or equal to sum of a logarithm. So at most you have n, right? And then you have m, right, in total. So this is bounded by m times logarithm n. And then, so this one, you know, it's O of n. So overall, it will be O of n plus O m logarithm n. So this is an upper bound. I would say I write less or similar, right, to this number. This is the term complexity. So that's one part. Another part is that if you have difficulty in understanding this, you can actually do some prints, right? For example, let me do some print here. Let's see, query and value and the corresponding length of the corresponding indices list. And then here I'm also going to print let me do this. I'm going to print it here. IDX and what's the temp or the distance. So now you can run it. So here, what's the problem? So here, syntax error, else. Here, let me copy and put it here. Oh, sorry. Let's see if I can copy this part. Yeah, I just need to delete this part. Yeah, that would be good. So you can see here, when query equals 0, the value is 1, the length is 3, so the temp is 2, right? So here, for this one, it does not appear since the reason is that for this one, you just have one occurrence. It does not enter this loop here, the else part. And then when query equals 5, and then the value is 3, and the length is 2, the temp added is 3, right? This is the one example. You can also see example 2. So because all the values are unique values, therefore it never go into this else block. So we just have those. And another example I see is this one. So you can also print the query, the value, and the length. If length is 1, it does not enter the else block here. And then, so those you have this corresponding to negative ones, right? So here you have 6 and 6 and 2. That's the right one. I guess with that said, I'm going to comment out this one, because this is for understanding. I'm going to submit it again. Yeah, so that will be the final version of the solution. With that said, I guess that's about it for the current video. We have a binary search playlist. You are welcome to practice those questions there. Thank you for watching.